Hi, Math 2 Enhanced. This document can be found as a PDF in our Unit A quadratics folder. So we're going to talk about projectile motion problems. These are problems that involve the soccer balls being kicked or rockets being launched or rocks being tossed off of a cliff. And so let's get started with the first one. It says the equation and the h of t means height. And so this negative 16 t squared, this is time squared, has to do with gravity. The 64 would be an initial velocity. The 960 would be an initial height that our rocket is launched from. For example, if you can think of having a platform and your rocket is on top of the platform. So in this case, it's a cliff, if we read ahead in the problem. So it says, what time does the rocket hit the ground? So there's some parts of this that we need to think about. So if we think about our XY axis, X being time in this case, so it's really time, and our Y axis, which is really the height, then in this case, we start with our rocket being launched. Our rocket loses momentum and speed and starts to fall back down to the ground. And our rocket hits the ground when the height of my rocket is equal to 0. So I want to know at what time that takes place. I want to know the time that's elapsed. That would be my t variable. So my h of t, my height variable, is equal to 0. And I'd like to solve for my t variable. So generally when I have these types of problems right here, I have 4 ways to solve this. Factoring, taking the square root of both sides, which doesn't really work in this case. The completing the square, which isn't a great idea because I have a negative 16 out in front. Or quadratic formula, which always works. Generally, I would use quadratic formula. A is negative 16, B is 64, C is 90. However, this problem does factor, and the way I'm going to solve it in this video and in the classroom is by factoring, just to give more factoring practice. But in general, I want you to know, usually this type of problem, throw your A, B, and C into the quadratic formula and get your answers. So here we go. So I'm going to factor this, but conveniently, there's a GCF of negative 16. Why I love taking the negative 16 out is because when I do that, I divide negative 16 t squared by negative 16, I get positive t squared. 64t divided by a negative 16 gives me a negative 4t, and 90 divided by a negative 16 gives me a negative 60. And yes, that was all on purpose. I wanted a factoring problem that we could solve by factoring. So now the t squared minus 4t minus 60 really becomes my diamond method with a negative 60 on top. That's my A times C, a negative 4 on the bottom, that's my B. And I think about my numbers, and it's 10 and 6, and the 10 has to be negative. So this is one where my A was 1. So I can just write my side numbers in my parentheses. It's the shortcut one. So I have a t minus 10 and a t plus 6. So I need to keep going to solve this. The negative 16 is a coefficient. There's no variable there. Negative 16 can't equal 0. There's no t on the outside with the negative 16. So I'm not going to do anything with it. It's not important. However, my two factors, t minus 10 could be 0 or t plus 6 could be 0. So I add 10 over and I get time at 10 seconds. And then I subtract 6 over and I get negative 6 seconds. So if I think about my drawing, the sketch I made, this is my negative 6 seconds, but that's back in time and it makes no sense in context of a rocket launch, so I'm going to get rid of it. And then my 10 seconds is the other time my height is 0, and so that's when it lands on the ground. It lands on the ground at time equals 10 seconds. So part B says, what time does the rocket reach its max height? Well, this is the vertex. I'm talking about the vertex at the top here. The vertex has an XY coordinate. In this case, it's got a time height coordinate. So my max height occurs at a certain time t. That's the variables of my vertex. So what I really want to find here when I want to find max height, the time, is I would like to find my vertex And for the time, I want to find the x coordinate of my vertex. So if you remember, we have that handy dandy equation, x equals negative b over 2a. So when I apply that to this problem, that's negative 64 over 2 times negative 16, negative 64 over negative 32, that's positive 2. So at 2 seconds, I reach my maximum height. So this t up here responds to 2 seconds. So on the next problem, it says, hey, what is that maximum height? This again is concerned with the vertex. However, my max height would be the y coordinate of my vertex. So since I know the x coordinate, I'm going to substitute it in. That's my time, my t. I'm using x and time interchangeably for height and y here. So I'm trying to find h at 2 seconds at when t is 2. So I'm going to plug that in. This negative 16 is a coefficient out in front. It is not being squared, just the 2, just the time, plus 64 times 2, plus 960. So be careful how you put that into your calculator, but when you do so, you should get 1,024 feet. So up here, my vertex was occurring at 1,024. You could graph this equation on Desmos. We're going to talk about how to do that in class, and double check your points by moving your cursor along the graph and finding when it hits the ground and when you have a max. So let's continue on to the next problem. The next problem is about a tennis ball. This problem gives me my function. This is my height as a function of time. I can put in any amount of time and find out how high my tennis ball is after it's been tossed up into the air. So it says, what is the height at 0.6 seconds? So this is my t. If I want to know my height when t is 0.6 seconds, I simply substitute in 0.6 for my time. So let's substitute 0.6 in for my time. And the negative 16 is a coefficient. It's not being squared. Plus 12 times 0.6 plus 10. And be careful, put that all in your calculator. I believe you should get 11.44 feet for your height. So let's go on. It says when, the next question, when. So now I'm looking for a time. When will the ball have a height of 10? So now this is what my h of t is equal to. This is what my height is equal to. So the entire equation is equal to 10. So I'm going to set my entire equation, negative 16t squared plus 12t plus 10. And now I'm going to solve it. Remember, we can't really solve without getting it equal to 0. So let's subtract 10 from both sides. I get 0 equals negative 16t squared plus 12t plus 0, so it's done. So this has two terms in it. You might remember when we are factoring, for instance, sometimes we can look for GCF or difference of 2 squares or difference of 2 cubes. This happens to have a GCF. My GCF in this problem is 4t. I'm going to take out a negative 4t just because I like my first term to be positive. My leftovers after I divide by negative 4t would be positive 4t minus a 3. Notice the sign change because I've divided by negative 4t. By the way, you could do this with quadratic formula. Your a is negative 16, your b is 12, your c is 0. Plug it all in. You're going to get the same answer I'm going to get. So these are my two factors. They're equal to 0. So I know negative 4t equals 0 or 4t minus 3 equals 0. So when I divide both sides by negative 4, this height occurs at time t equals 0 seconds, or it occurs at add 3 over, divide by 4, t equals 3/4 of a second. Those are the two times that I am 10 feet high. So now it says, when will the ball have a height of 15 feet? So this is really the same problem as up above. I want to know when I will be at 15 feet. So I'm going to set my height equal to 15. So negative 16t squared plus 12t plus 10. Plus 10. So again, I'm going to start by subtracting 15 from both sides. When I do that, I get negative 16t squared plus 12t minus 5. Now, when I look at this problem, this doesn't look factorable to me. I don't really want to play with it. I'm going to go straight to the quadratic formula. So I'm going to use negative 16 for A. I'm going to use a positive 12 for B and a negative 5 for C. Let me get a different color to kind of keep things separate. So my t, or my x, this is my quadratic formula, equals negative b, so negative 12 plus or minus b squared, which is 144, minus 4 times a times c, lots of things going on there, all divided by 2 times negative 16. But watch what happens when we clean up underneath the radical. So we got a negative 12 plus minus. Down here, this is a negative 32. But underneath the radical is a bit of an issue. So you have a negative 144. Now, a negative 4 times a negative 16 is a positive, but times a negative 5 is a negative 320. 144 minus 320 is going to give me a negative number. This is bad. A negative number under the radical would give me an imaginary answer. In other words, it doesn't exist. So technically, I can stop here. Stop. I know if I kept going, I would get an imaginary answer, a complex number. So this doesn't exist. There is never a time when my tennis ball is 15 feet high. So there's never a time my tennis ball is 15 feet in the air. So then it says, when will the ball be at its max height? Let me slide this up a little bit. So what is the max height? If it's never going to get to 15, it's going to be something a little bit less than 15. Let's go find it. Remember, this is the x coordinate of my vertex. That's with the when. The when is the time. So it's the x coordinate. I keep changing my marker. The x coordinate of my vertex. We know that x is equal to, in this case, x is time. T is equal to negative b. So in this problem, it would be a negative 12 divided by 2 times a, which is 2 times negative 16. It's negative 12 over negative 32. And if you divide that on your calculator, I believe you get 0.375 seconds. This is the time that my max height occurs. So in E, it asks, what is the max height? Well, I'm going to plug in my time, my x, to find the y coordinate of my vertex, which is my height in this projectile motion problem. So let's go find what h of 0.375 is. So I'm going to do negative 16 times 0.375 squared plus 12 times 0.375 plus 10. If you plug all that into your calculator correctly, you should be getting approximately 12.25 feet. That would be my max height. So now the last problem, almost there, almost done with this one. Oh, actually, no, we have 2 more. It says, when will it hit the ground? So now my tennis ball has been up in the air. It reached a max height of 12.25 feet, and it starts falling back down to the ground. When? What time will its height be 0? So I'm going to set the entire equation equal to 0. So 0 equals negative 16t squared plus 12t plus 10. So again, usually I would just plug the negative 16, the 12, and the 10 into the quadratic formula and call it a day. However, this is factorable, and it's a factoring problem that involves an a that's not 1. So I'm going to do this at this time with factoring. You are more than welcome to do it with quadratic formula. Just make sure our answers are the same. So here we go. Again, I'm going to factor out a GCF. I'm going to factor out a negative GCF of 2 so that all my signs flip and my first term has a positive coefficient. So I get an 8t squared minus, careful, 6t minus 5. So, by the way, if you're asking how I knew it was factorable, I planned this problem to be factorable so I could use this method with you for review. Again, this typically is the kind of problem I would just go to the quadratic formula. get my answer, call it a day. So let's keep going. So, because this was completely planned, that I would do my diamond method, and I would get a negative 40 at the top. That's my 8 times negative 5. I get a negative 6 at the bottom, and I think, and I realize my numbers are 10 and 4. And if I want the negative 6, my numbers are negative 10 and positive 4. So now we're going back a few class periods, but this is where I rewrite the 8t, rewrite the minus 5, and now I'm going to put the negative 10 in as a negative 10t and the 4 in as a positive 4t, and these two numbers are replacing the negative 6t. It allows me now to switch up to do factor by grouping. So I'm now going to group my first two and my last two. And I get 0 equals negative 2. Looking at my first two, what's their GCF? 2t? So we get what? 4t minus 5. Now, the second set of numbers doesn't have a GCF, but I have to pull something out. It's going to be a positive 1. 4t divided by that 1 is my 4t. Negative 5 gives me a 4t minus 5, which is what I want. It matches. My two parentheses match. So I'm going to factor them out, and I now get negative 2 times 4t minus 5 times 2t plus 1. So I'm not yet done. This is where quadratic formula probably was even faster. So now the negative 2 doesn't do anything with my 0. There's no t with it. It's just a coefficient. I could divide everything both sides by negative 2. It literally just goes away. It has no effect on my 0. So either my 4t minus 5 equals 0 or my 2t plus 1 equals 0. So here I would add 5 over, divide by 4. So t equals 5/4 seconds. That is also 1.25 seconds. However you want to think about it, top heavy fraction or decimal, doesn't matter. And subtract 1 over, divide by 2, t equals what? Negative 1/2 seconds. Again, that's the 0 that doesn't make any sense because you go back in time. So when will the ball hit the ground? It will hit the ground at 5/4 seconds, or if you want to think about that, probably if you were doing the quadratic formula, you got 1.25 seconds. So let's finish off this problem, domain and range. So let's look at our graph for just a second. You don't need to look at your graph to figure out your domain and range, but it's kind of nice to see what we got going on here. So I have a graph. I know it starts at 10 feet because that's my y-intercept. That's my c. If I plug a 0 in for t, I would get 10. So my graph looks a little bit like this. It starts at 10, a height of 10. It goes up to its max height. The max height is at the vertex. I think we decided that was 12.25 feet. This is my vertex, and it occurred at 1.25 seconds. Oh no, that's when the ball hit the ground. Let me erase that. Looking back up at D, at 0.375 seconds, that's when I was at 12.25 feet. So this is 0.375 seconds. And then it hit the ground at 1.25 seconds. And we also did another part of the problem where we wanted to see what time. It was 15 feet in the air, and you can see that it never was that time. That's why I got an imaginary answer. That's why I couldn't find a time for that, because it didn't happen. So then over here, this is my negative root of negative 1/2. But remember, in real life problems, that doesn't make any sense. So as far as this problem goes for real life, my x values go from 0 to when it hits the ground. So my domain goes from 0 to 1.25 seconds. And my y values, that's my range. My y values start, my lowest y values when it hits the ground. So I do have a y value of 0. And my y values go all the way up to the height, which is 12.25. So for this tennis ball, the time it spends in the air is between 0 seconds and 1.25 seconds. And the height that it reaches is from 0 feet when it's on the ground up to 12.25 feet when we're at its height. So I want to take a moment to do number 4 with you from the backside. The backside is somewhat review from graphing that we did in class and the things we know about our graph. But let's take a quick look at number 4. It says, what's the vertex? Is it a max or a min? So this is in vertex form, y equals a times x minus h squared plus k. So I know when I'm looking at a plus 6 and seeing a plus 6, that really the x coordinate of my vertex is the opposite of that. It had been a negative 6. That's how the negative makes it look like a plus 6. So my vertex is at negative 6, 3. And because my a is a positive 1, I know my graph, when I go to negative 6 and up 3, I know my graph looks like this. So in this case, I know that it's going to be a minimum. Now, what's the y-intercept? So because I didn't take time to graph it nicely, I can't get my y-intercept from my graph. I'm going to use algebra. My y-intercept occurs when my x-coordinate is 0. So let's plug a 0 in for x. So I get y equals 0 plus 6 squared plus 3. So that would give me 6 squared when 0 plus 6 is 6 plus 3. 36 plus 3 is 39. So it looks like my y-intercept occurs at 0.39. So then let's talk about our x-intercepts. I already realized that it doesn't cross the x-axis because it starts above the x-axis, my vertex, and it goes up. But how can I see that algebraically? Well, one of the things we've learned about in class are imaginary numbers, complex numbers. So let's take a quick look at how that looks in a problem. If I set, this occurs when my y-coordinate is 0, my x-intercept. So I set y equal to 0, and I have x plus 6 squared plus 3. We talked in class how this is not a candidate for factoring, completing the square, or quadratic formula because it's not in standard form. Because it's in vertex form, this is solved by taking the square root of both sides. So before I take the square root, I'm going to isolate my squared term. I'm going to subtract 3 from both sides. I get negative 3 equals x plus 6 squared. I'm going to take the square root of both sides, and right now you can see where my imaginary number is going to come out of the, this is going to give me plus minus I square root of 3 equals x plus 6. My last step is to subtract 6 from both sides. We've talked in class how we just put that number in front of the plus minus. So I ran out of room. I get negative 6 plus minus the square root of 3. This is two numbers, negative 6 plus the square root of 3 and negative 6 minus the square root of 3. That refers to my roots, you will, my x-intercepts that I'm getting for that. This is a complex, sorry, so sorry, I forgot the I. Please go put the I in right there in front of the square root of 3. So the negative 6 is the real part. The I times the square root of 3 is the complex, or is the imaginary part. Together, it makes a complex number. This is an answer, but it also tells me that there are no x-intercepts. There is nowhere where this crosses the x-axis. So then write in standard form. So part D, this is when you have to multiply it out. Like I said in class, my biggest hint to you is write the x plus 6 twice. It's squared. Make sure you're going to really truly square it by writing it twice. So y equals x plus 6 times x plus 6 and then plus 3. So I'm going to do my multiplication out to the side. Do your box or foil, take your time, get all of your terms, combine the inner and outer term. You should get x squared plus 12x plus 36 plus 3. So your final answer is, see if I can squeeze it in here, x squared plus 12x plus 39. So Math 2 Enhanced, I hope that was helpful. If you're struggling with other problems on the backside, shoot me a message, come see me during office hours. We'll get it figured out, ask in class. Talk to you guys later. Thank you.